All right, guys, we are doing Unit 3, which is conic sections, and just basically the definition of a conic is presented on the screen for you. A conic section is the intersection of a plane, so you think of almost like a sheet of paper, and a double napped cone. So if you see the double napped cone, that's just like one cone sitting on top of another. And if you slice that cone, we look at what shapes are being formed. If you see in the first problem here, if you slice it completely horizontal, you're going to get this circle. And then if you see this, you're slice diagonally, we have something called an ellipse. So you know that an ellipse is not a perfect circle, it's what we would consider an oval. My drawings are pretty rough. Here, if you slice it on a diagonal, you also could get what we are very comfortable now studying is parabolas. And you've studied parabolas probably since 8th grade. All right, and then the last one, I'm just erasing these markings. The last one is a hyperbola, and you've studied inverse hyperbolas, but not just all types of hyperbolas. So we're going to be talking about that in this unit, and we're going to start with the parabola. So last year with the parabola, you should have learned the equation of a parabola other than what we're comfortable with, which I think in 8th grade you probably saw y equals ax squared plus bx plus c. That's our general equation of a parabola, but last year we saw that a parabola could be written in terms of a directrix and focus with information given. So basically what they're saying is a parabola is a set of points. So this blue parabola here to the right, I'm going to try to match up with it, with this, is going to be created by being equidistant from the focus to the vertex and the vertex to the directrix constantly throughout. And that's what they're showing you here, that this line here is the same length as this line here. So these set of points that are going to be equidistant from the line and a point at the same time is how a parabola is constructed, formed. So now the information that we get off of looking at a parabola in terms of focus and directrix, there's a p-value. You probably remember seeing this equation last year written to be y equals plus or minus 1 over 4p x minus h squared plus k. And you knew that hk, so I'm just going to put this over here, if I took out the h and kept the k how it was, that represented the vertex, which is right here. That's your vertex. All right. However, we needed to know what p was. All right, p is the distance between the focus and the vertex and or the vertex to the directrix. So that spacing is considered our p-value. Just for pre-calc purposes and how you're going to see this in college textbooks, we rarely see the equation written like so. Instead, I'm going to present to you the equation that we normally see, where it would be, oops, let me try to get this pen over here, plus or minus 4p y minus k in a parentheses is equal to parentheses x minus h squared. Now, it really is the same exact equation as this. It's just in this equation here, which is more commonly used, we minused this k over, and then we went ahead and multiplied both sides by 4p, and that's where we got this equation. And this is the equation we basically use when we're dealing with conics, with parabolas in this section. How do I recognize that this is a parabola? You have one variable squared, and when I'm talking about one variable, I'm talking in reference to x or y. If you have x and y and none of them are squared, none of those variables are squared, we're talking about a linear function. If you have x and y, and either the x is squared or the y is squared, then we have a parabola. All right, so the standard form of the equation of a parabola with the vertex of hk is going to be, as I said, right here. And this p cannot equals 0 basically is just saying that you can do the problem, all right? So, like, yes, that's necessary. You don't have to ever include that, but that notation is just there to tell you, obviously, if it was 0, we would not have an equation. So p could never be 0. You need to have some distance from the vertex to the focus. Let's talk about some pieces that are important as well in reference to the focus and other properties of the parabola. The axis of symmetry is this vertical line that almost, does divide the parabola in symmetrical halves. So like if I folded this parabola over this red dotted line, this red dotted line is called the axis of symmetry. The point, the focus, I could put that in green because that's what it was. So that focus always lies on the axis of symmetry. All right, so that's like one bullet that you want to remember, okay? That you always have the, oops, let's undo that little error. So you want to write here that focus, that point called the focus, always lies on the axis of symmetry. And I'm just going to write axis of symmetry as AOS. The next piece that you should know is that the directrix, which is this line right here, is going to be perpendicular to the axis of symmetry. So that's another piece. The directrix is perpendicular to the axis of symmetry. So if you have a vertical axis of symmetry, your directrix is going, and for example, x equals, let's say 2, your directrix to be perpendicular, what's perpendicular to a vertical line is a completely horizontal line, and it's going to be y equals. And to be more specific on what y would equal, I'm going to go back to the idea that this vertex is known as x minus, nope, not x minus, sorry. Let me take that off. This vertex is h comma x, correct? So that's coming from here, right? H comma x. And we know this distance from the vertex to the directrix is p units away. So when I'm trying to calculate, well, what's the equation of the directrix? I know it's y equals some constant. Well, it's going to be, if I look at this, what I'm looking for is that y value. I'm going down that y value, p units, right? So it would be take your y value that you have of your vertex and subtract the p value, which is the distance between the vertex to the directrix or the vertex to the focus. So that's something that's nice to know. I honestly don't memorize that. I think that it's just organic to figure it out while you're looking at the equation. But if you like to have steps and something to reference, you could definitely use that. Your axis of symmetry, because it goes through the focus, just to be a little bit more specific on the axis of symmetry, we know if it's a vertical line, it's going to be x equals a number, and it's not going to just be any number. It's going to be the h value of the vertex. So your axis of symmetry is x equals h. Okay, let's move on to the next slide. So this is a little different for us. This is also a parabola. How do I know that this is a parabola? I see x and I see y and I see just one variable squared. X is not squared. So this tells me, oh yes, I have a parabola. So parabola has one variable squared, the x or the y. When you have an x minus h squared, you have a parabola that opens upward or parabola that opens downward. But when you have a y minus k squared, well, now this is where you're going to have a parabola that opens to the right or to the left. And that's different for us. I mean, these sideways parabolas are not functions, but they are conic sections that we would be required to be able to represent through an equation. So when you have a sideways, parabola, we have a horizontal axis of symmetry. Now my vertex is still going to be considered h comma k. Okay, the only difference is what I said, is the squared is coming off onto the y value. That p value is still going to be the distance between the vertex and the focus right there. Okay, so that's still, and let me just change the color on that so you can kind of distinguish what I just did. The p value is still going to be found from here to here. That's our p value. But regardless, if I have my axis of symmetry, and you see that line, that red line divides it in half, I know my axis of symmetry here is going to be a y equals equation because it's a horizontal line. And what's the y value of that vertex? It's y equals k. And your directrix, right here in the blue that I'm going to change this marker to be, is a vertical line because we said the directrix, and I'm trying my best to make this a perpendicular, has to be perpendicular to the axis of symmetry. So we know that the directrix is going to be x equals, and again, for a little help but not necessary, you could just figure out what h is and subtract p. That's going to tell you what your directrix is. So here's my vertex of h comma k, and then if I subtract p units from that h, I'm going to land at the directrix line. All right, again, it's something that, like the equation for the directrix, I just usually just count and just make my equation just by graphing it. So let's get to start do some practice problems. The next slide, and hopefully you're following along on the worksheet. It says write the standard form of the equation of a parabola with a vertex of 2, 1 and a focus of 2, 4. My very first step for you is to go ahead and give it a sketch. So I want you to plot this because right now I have no clue. Is it opening upward, downward? I'm not sure. So here comes 1, 2, and 1. I'm going to plot that point, and I'm going to call that point a vertex, so V. Then my focus, I'm going to plot as 2, 4, so I'm going 1, 2, 3, more up, and I'm here. Now I know, oh, this parabola opens upward because the focus always lies within the parabola. So when I'm constructing, when I want to construct this parabola, I always say that the parabola hugs the focus. All right, so right now I know, oh, I'm going to use the plus because it's opening upward, 4p, x minus, nope, not x minus, y minus k. So sorry, I'm looking at the time. I'm actually going to pause because I'm going to get cut off and I'm going to start a new video. So link up to the next video.